Hi everyone, I'm DJ Cole. I'm part of our Cisco IoT group at Cisco. Really what we do is we call ourselves Cisco IoT, but more or less what we actually do is create all sorts of industrial networking technologies to connect things, right? So overall, a lot of Cisco's focus is users overall, connecting users. We kind of focus more on the hardware technology that you use to connect things to your network. That could be anything like an AGV, it could be sensors, could be automated equipment for industrial networking, all sorts of things. And what I'm here today to talk to you a little bit about is switching and wireless, some of our new innovations that we have, really that we can extend that Cisco technology, but located in locations where they're more harsh, right? So when you think harsh, that's environmental, either temperature, humidity, vibration, even things like hazardous locations where you have explosive gases. Um, Got the question last time I did a tech field day of what about space? Right now, we don't have any products that you use in outer space, but pretty much anywhere on Earth that's within kind of the human realm of what you're expected to do, anywhere from like -40 to about 65 Celsius, our products will work pretty well in that range. Canada, we have a lot of customers that deploy these in Canada, especially oil and gas. Right up there, like above the Arctic Circle. With a little bit extra consideration to bring the temperature up, definitely very possible. So with that, I think I mentioned it, but I'm going to be talking about switching, and then I'm going to be talking about some of our wireless products. So first off is going to be switching. When you think about Cisco switches, you usually think about our Catalyst series of switches, maybe Nexus, but Nexus obviously is definitely more data center. But when you think about Catalyst, they're kind of out there sort of anywhere from your distribution to access layer in your network. But you're typically going to put those in computer rooms or maybe IDFs. But most of those IDFs, those computer rooms, they are going to be kind of air conditioned, right? You're not going to put these outside in a cabinet along the side of a road with no air conditioning. Catalyst switches would probably work, but definitely going to struggle when you think about something like summer or winter when you have extreme temperatures. So we're coming out with actually 5 new switches. These are all under the Catalyst line, but we have that extra part of that. We call them the Catalyst IE or Catalyst Industrial Ethernet switches. And here we're going to kind of go through those 5 models. So think of basically from a from a software perspective, everything that you have on our Catalyst switches in terms of switching feature set. Some of the features are a little different. But from a hardware perspective is really sort of where those changes happen. We're releasing 5 new models. This is the sort of the first one of them. This is an all fiber switch. And when you think about sort of industrial switches, usually they kind of lag behind a little bit what you see in enterprise, right? So we don't have anything that starts approaching like 400 gigabits per second or anything like that. But this switch is actually an all fiber switch. We do have a few sort of copper uplinks, right? That kind of is a great addition. Think of some of the places I'll talk about where you can deploy this. But imagine if you're putting this in a cabinet, you're running fiber out everywhere, but maybe you have a UPS or something or access control for the cabinet that you just want copper. You can do that without having to plug a SFP into that switch. So this specific model is really made for aggregation. So if you think about something like roadways, what you may not realize is when you drive around, you have all those like traffic lights and other things, other infrastructure around the road. There's a lot, some locations more than others, but some locations bury a lot of fiber in the ground, right? When they're doing road projects and when they've done road projects for the last 10 years, they put like, some organizations, their kind of standard count on fiber strands is everywhere they do road, everywhere they install new traffic control devices, it's all 144 pair or greater, right? So there's a lot of fiber buried in that to support new devices along sort of the infrastructures and roadways. So they need a switch like this to sort of aggregate all that fiber, right? So you might not see this at every intersection, but maybe those major intersections where those fiber cables cross and start going down different corridors, they'll have a switch like this where they can actually have that sort of aggregation fiber point. And for the most part, those switches are in unconditioned cabinets along the side of the road. So you need something like this that for depending on which state you're in, can either go for low temperatures or high temperatures during the summer. In addition to that, sort of when you start talking about substations, some of the extra features on this switch is the ability to do high precision timing, which is really more critical for something like a power utility or a substation where they actually need, they use that precision timing to actually do some of their synchronization of the power grid based on that, right? So you'd hook up a GPS antenna to one of these ports, that one right there, on the switch, and then it actually puts out PTP. It acts as a PTP grandmaster, which simply means it's sending out really precise timing packets so that devices on the network can read those and know what time it is. And when you're talking about that, it's like in the nanosecond range of being able to synchronize time. The next switch that we are releasing is very similar, but kind of the port have changed a little bit. This one is primarily a copper switch with some 1 gig and 10 gig uplinks. This is, if you're coming from the Cisco Catalyst switch world, seems pretty obvious. But when you're talking about an industrial format, this is kind of one of those new innovations where now we have this port count, and it's not just the port count, but it's also kind of skipped over at the beginning, but this port count in an industrial form factor with IOXE running on the back end, right? So if the rest of your infrastructure is iOS XE on Catalyst 9300 series switches, this is the same thing, but in an industrial format.
Are the SFP pluses similarly rugged?
Yes, so it depends on the specific SFP, but like when you look on our data sheet for SFPs, we have some that are enterprise grade. Usually that letter at the E, the letter at the end of the PID will indicate the temperature range. So we have the standard range, we have an extended range, and then industrial range. So a lot of the options, like the 10 gig long range, may not be an industrial range, it may be extended. But definitely, we're working on getting towards that point where more and more, as technology increases, more of those higher speed will have an I range available. But it does depend per SFP, just because we have so many of them. Can't say they all are, but we definitely have options. Question?
That picture, I don't see SFPs on that.
Right here.
Okay.
The SFP slot.
They look like copper, so that's fine.
No, those ones are SFPs.
All right.
Yep. So then the 4X, that means that it is a 10 gig capable SFP. This is similarly useful as the last one, but this is really more towards sort of the access and distribution layer. So when you think about, same kind of substations, this could be in a roadside cabinet for, if you had a number of devices, but it's not going to be doing that aggregation. But really where you kind of think about here is any place where you need a switch, but you don't have the environmental room to do it. You can do something like that here. We talk about dusty IDFs, and it's not just the environment, but it's also sort of like where you put the entire cabinet. Imagine you're doing this in, say, I think one of the really good examples was underground subway system. And even though that they had their switches in a room that was sort of temperature controlled and was underground, so didn't have a lot, what they actually saw was brake dust. Excuse me. The brake dust from the train is getting into the room, and because they had just normal enterprise switches with fans on them, they would kind of suck that dust that did get into the room through the switch. And being that it was brake dust, it was kind of it was conductive, and it would all after a few years, it would just basically start shorting out components on the board after it built up, right? So a switch like this, well, this switch would have a similar issue if it got that same dust inside of it, right? But because there's no fans, you're not actively pulling that dust through the switch. It's much easier to keep it out of the environment.
Can I ask you to take a step back and just how about 2 or 3 things that make these physically different than?
I'm actually going to talk about that afterwards. So I kind of put it out of order, but I'll get there. And if not, you'll have questions. I just kind of do the whole what do we have first? But I have a few slides talking about how they're actually different. And then just to wrap up the portfolio, same kind of thing, except with PoE on it. We're seeing a lot more requirements for PoE. So the first 2 switches, the first switch has PoE plus on the first set of ports. The last 8 ports are high power PoE, so up to 90 watts of power. UPoE or 802.3 BT. And then the other ones are just all 30 watt PoE plus, with the last one being a 1 gig uplink, just kind of depending on what you need, 10 gig or 1 gig uplinks. Really what we're seeing is, for these type of use cases, but even really could be any use case, is the need for more PoE as we have things like power, have access points, especially like the access point that I'm about to tell you that requires 45 watts of PoE. Those high gain ports are useful, and also security cameras, right? Everything, even what you see here, but even things like substations out in the field, they need PoE for access control now, and they're starting to put a lot more cameras out there for somewhat obvious reasons. So we're seeing a lot more of the demand for that. And all these switches have up to 720 watts of PoE budget for them. Here's sort of this is actually a picture that I took from the show floor here. This is all of the IE 9300 series switches together. Total with the 5 that we've announced, during the show. That brings us to a total of 7. If you do happen to go down to the showcase at all, check that out. We have all of them there. I couldn't bring one. Each of these switches is about 30 pounds, so you can imagine if you have a rack like that with all 7, how much that weighs. So, kind of to your question of what makes these switches different than our industrial switches. And a lot of it comes down to the actual engineering, right? So this is a top view of one of these switches, and you can see inside. The biggest difference that I mentioned is there is no fans, right? So everything is pretty much solid state. Nothing moves inside of these. I'll talk in a second about how it differs from an industrial switch, but off the top, the big thing is the field replaceable power supplies are a little different. What you're used to in a catalyst switch is where you pull it out of the back and you have the power plug that goes into the PSU. Ours is a little different in that respect, where the PSUs are actually in the back. They're field replaceable. Of course, there's no fans, so those you don't have anything to replace there. But the actual power input comes in the front of that, and that's usually kind of preferred for our industrial customers, so that all the wiring is from the front, right? So if you take this switch and you stick it in a cabinet, the wiring is on the front, it's not on the back. Of course, if something happens to the power supply, you still have to get access to the back of the switch. But generally, this is sort of what we've went with in about the last 3 generations of our industrial rack mount switches. The second big part is the cooling, right? So without any fans, we have to dissipate all that heat. And one thing that I probably didn't quite mention during the last few slides is that all these switches are stackable, right? So not only does the cooling have to work just when you have one switch, but it also has to work if you stack these, right? And these are stackable up to a series of 4. So they could be 4 in a row. They could be all next to each other, or
on that. So in that last image, they had them separated by looked like 1U.
Mhm.
Can they be next to each other, or
They can.
Okay, that was
So
just for the show.
On the last picture, the biggest reason is so they could put these little strips here. But yeah, they can be spaced closer together.
Well,
Definitely.
Okay, I see 2 are right
Yep.
next to each other.
Definitely, there's considerations on heat, depending on how many you have, what your load is. But they can be stacked together. And that was a good question for what I was going to talk about. So when you see all these copper tubes, a lot of that is to move the heat to different areas. So we have these cutout sections of the switch, and you can actually see through these fins when you're actually looking at it. But when you stack them, these fins all line up, right? So you basically have this like heat stack inside the switch. So the cooling is actually done by convection, right? So if you have one switch, the air just comes in and then comes out the top. But even when you stack these switches, all of that heat from all of the switches comes up these basically like heat stacks and comes out the top of all the switches, right?
So the top is vented?
Yeah, I mean, granted, you're not going to put like a bunch, right? But if you have a small cabinet, you have 4 switches, you stack them all next to each other, 1U, 4U total. All of these are basically open to each other, right? So
the heat from the bottom will pop out
Yep.
the top.
it's like a whole convection stack. That's one of those differences, where you have your typical catalyst enterprise switch is right one way to the other, and it's expelling the heat. The way that you get around stacking something with no fans is having those heat columns where all the heat just can rise through all of them. So when you stack them, you basically just have these fins and it's all open through it. So it's kind of cool to see in person. Definitely, if you get a chance to go down there, you can actually see one of them with this cover.
As long as the intern mounted them all the same way.
Yeah.
And I guess if you have a bunch of them,
Yeah.
you can put your hot dog to heat it up.
Certainly. And I think that's true for all of our products inside of IoT. A lot of them are, we dissipate the heat through the chassis, so they all get really hot. They have little stickers that say, "Don't touch this; it's hot. You might burn yourself." Yeah, definitely. Not gonna. Hot dog's a good one because it's already cooked,
Not
pre-cooked.
marshmallows, because they would just get in there and
Yeah.
Don't like piercings.
Details.
It's a little late in our day.
squirrel. Come on.
You put it inside of a little plastic tray or something. So just kind of going back to really your question in general, but what makes it different from an enterprise switch? Really the biggest thing is that temperature range. All of the 9300 switches can do -40 to 75. We test it in the factory at those temperatures, so we make sure that every switch, there's nothing wrong with any of those switches that we manufacture that's there. And we do type testing outside of that range just to make sure that, if it occasionally goes above this, it's not going to completely fry the switch. As considered, most of our enterprise products only go up to roughly 45, maybe 50 C.
One of my coworkers was interested in that number. I have to convert it to freedom units for
Yeah,
him.
we'll convert that
But,
for you guys later.
So like
The first one's easy. Negative 40 Celsius is negative 40 Fahrenheit. Got that one.
Florida, we're not going to ever hit that low. But our thing is particularly where we have like stuff out at a ball field or someplace like that. It's in an enclosure. Unfortunately, often a metal enclosure in the middle of the sunlight, but you do what you can. And he's like, well, they survive it, and looks like they will at 75 C as long as So yeah,
yeah. Keep in mind that's ambient temperature, right? So obviously the switch is going to get much hotter than 75, but 75 ambient.
Yeah. And to point out, we can see that that heat dissipation point.
Yep. Yeah. This image is easier.
I think the only time I've seen something like this, not the exact one, die is been they were hit with lightning.
Yep. And one of those things.
You have to take it direct.
Down there, right? So the EMI immutability, not necessarily directly lightning, right? If I think any of our switches, if lightning hits it directly, it's going to have a problem.
The tower, it didn't hit it directly.
Right. But the biggest one, especially if you're in some industries, having more immunity to, industrial power surges, right? Because power surges aren't always lightning. Some of them are generated by equipment. This switch can take that a little bit better. But, that also means that if you do have good lightning suppression and you hit somewhere near, this switch will have more room to operate normally before it gets damaged by lightning. Yeah, so one of the other big differences is app hosting. So I guess I could go back to the beginning. I was answering the other question first. But the beginning of this slide is the reason I compare it to the Catalyst 9200 is that even though that we call ourselves the IE 9300, it's most directly related to the feature set of the 9200, but it actually it kind of shares parts of both, because when we go to industrialize our products, it's not like we can find exactly one piece to do everything we need. So sometimes we'll take architectures from the various products, but it's most directly compared, if you're looking at a data sheet, to 9200. The big difference there is we have IOX app hosting on this, so we can host actually like small Docker containers or other workloads on the switch, so that if you have something, say, some sensors out in the field, you can actually have some compute power directly on the switch to handle the processing at the edge before you send out to the data.
How are you implementing that then on there? You have
So we have a technology called IOX in Cisco, which is basically, there's kind of an application hosting manager, and you're able to, today it's mostly Docker containers.
Yeah.
You're able to go to a web interface on the switch, upload a Docker container and start that, and it basically runs virtualized inside of iOS XE on the switch.
So could that be like a thousandized agent?
What?
Thousandized agent?
Sort of. So really what we have a different sort of product called Cisco CyberVision that actually is made for sort of the industrial side of that. But generally anything that you can sort of adapt into one of those containers, you could do. We focus more on CyberVision because it's one of our IoT products. But yeah, we deploy, and not just this switch, but a lot of our IoT switches, we deploy the CyberVision sensors on those products to have visibility at the edge for our customers.
In places where the extreme temperatures, especially on the high end, are the concern, and fanless isn't necessarily a requirement. Would there be any option for a fan to actually go over that vent and sort of assist with cooling? PoE powered add-on fan or something like that?
Maybe we don't offer anything like that. But yeah, definitely anytime that you can move heat away from the switch faster, you can get more increase like that, right? Temperature, again, is only one of those kind of things you think about. It's also sort of dust. There's a lot of times where you will put a switch like this in an outdoor enclosure. Something like Florida is a good example, because you can put an outdoor enclosure outdoors and air condition it, but you don't necessarily want to air condition it down to like 85 degrees, because then you think about something like an airport that's really hot on the tarmac. If you open that door, that if you super cool that rack to say 80 degrees, you create a lot of moisture in it, right? So if you typically say, take an example of a customer that's in a metal foundry. They'll have an air-conditioned cabinet, excuse me, but they won't take it down to like 85 degrees. It still may run at 100 degrees, well within what this can do, but it's still able to dissipate heat away from it, right? And then that's going to be a closed-loop system where, they're not exchanging air, they're just exchanging heat out of the cabinet. So definitely you can put that in line with the fan, but we don't have anything like that in our portfolio directly. So the next thing, I have about 10 minutes, so I want to move on to wireless here. What we're announcing on the wireless side is what you pushed passed around. That's going to be our IW9167i heavy-duty access point. So Essentially, if you're familiar with our Cisco wireless portfolio, we on the enterprise side, we have the CW 9160 family, which includes the 9166, 64, and 62. Those are all Wi-Fi 6E indoor access points. This is essentially that same architecture, that same technology, but brought into a outdoor access point with internal antennas, right? And here you see some of those areas where that can be used. Really, any place that you have need for an outdoor or something that's a IP66, IP67 access point, you can use this for. Just sort of the specs and overview here of what this is. So this is a tri-radio access point. So when I say tri-radio, that's going to be the 2.4, 5, and 6 gigahertz, all 4x4, right? So pretty much the top of the line in terms of performance on what you can sort of deploy today, at least commonly available. One of the interesting things, of course, as we talk about IoT and we ruggedize equipment is that, other than the radome on this, which is plastic, obviously, because the RF has to get out, all of the back is a cast aluminum chassis, one piece. I'll show you what that looks like in the inside in a second. But that'll...
Lift that with your hand.
I've practiced.
Okay.
Definitely, I think a lot of the reactions is like this one the first time, is where you pick it up and you expect it to be a lot lighter than it is, and
It's sturdy.
sometimes I make sure I hold it so that someone doesn't drop it. But that gives it, a lot of that is related to the heat dissipation. I'll talk about that in a second. But of course, this is IP66, IP67, so you can deploy this anywhere. You can temporarily submerge it. I have a video that may or may not be public, trying it out in the bathtub. Definitely have one testing it out in the shower on my LinkedIn, but another video.
How temporary?
So IP66 is 30 minutes at 1 meter.
Yeah.
So
So it's fine for heavy rain.
definitely heavy rain and temporary immersion. I don't know of any use cases where temporary immersion is something that you do, but
Well, the rain in Florida could be considered temporary immersion.
yeah, definitely. So if you put this outside and you just get driving rain to it, as long as you install it correctly with the right glands and stuff, you'll keep that IP67 rating. Multi-gigabit, of course, this being a Wi-Fi 6E access point, the need for the uplink being greater than 1 gig is there. So this has two 5 gig uplinks. One's an RJ45, one's an SFP. We have optional M12 adapters. I'll tell you about what that means in a second. In addition to all that, there's a built-in GPS here, which is really required for the 6 gigahertz for the AFC that's upcoming in a little bit. And all that antenna for that is built inside. I'll talk about that in a second. It also has dedicated scanning radio. I'll show you what that looks like in a second, as well, at least the antennas for it. And one thing to note, if you're all familiar with our portfolio, I'll talk about this at the very end, as long as I don't run out of time. But this only runs Wi-Fi, right? So pretty much if you're coming into this new, that's what you'd expect. This is Wi-Fi, CapWAP AP. Can also do mesh mode, but pretty standard from the Catalyst Enterprise side. Standard AP, except outdoor ruggedized enclosure. One of those things that makes it ruggedized is the internals of it. So this is the internals of this access point. This is actually the front cover. So you looked at it, this is the plastic radome on top, and that is the actual case. One of the things how we ruggedize products is, of course, thermals. When our IoT hardware team goes and says, how do we make this ruggedized? They have to look at mostly thermals first. So there are some chips on the board that part of that ruggedization is going and finding components that can meet those temperatures. So a lot of what you would have from an enterprise product is replaced with a little bit more ruggedized components that can take higher temperatures. Some of those components, there just are not ruggedized versions of them, mainly like radio chips and SoCs. So some of those are actually designed with, those are sort of the heat points that we want to maintain the right temperature on the board. What you can see actually in this cast in this case, so these little metal like towers, I call them, are all cast as part of this case. They have heat transfer pads that sort of match up with these squares here, and that all mates together, sandwiched together when this is put together, pulling this heat out of those chips, sending it to the heat to the chassis, and then on the bottom is actually all these fins, right? They don't look like much, but those are fins to increase the surface area to make sure that we can dissipate as much heat as possible. Kind of unique here is this metal plate, which serves as the back plane to the antenna, but it also serves as another heat sink because there's components on both sides of this board. So that also, this big metal plate here that kind of sits on top of this chassis also has a role in dissipating heat, actually even through the front surface of the antenna. So Doesn't show the antennas in this picture, but imagine you have little bits of metal hanging off the backside. Even those antennas help dissipate the heat off the board, into this front cover, but eventually it comes out of the AP. One thing to note, just kind of cool, is what you see in this little corner here. These little white squares, that's actually what we call a GNSS window. You see that on this case here. There's actually one here and one here. Nope, up here. So you all can see it. Everyone's streaming. You see these little squares here on the access point. That kind of matches up with what you see on the screen. We call that the GNSS window. So this little tiny piece of metal here, which is the GPS GNSS antenna, it actually can see the sky out this little hole in the metal case. That lets you have the GPS location for the AFC. Also on the board, kind of to support this, is an altimeter, or a barometer, depending on how you use it. But essentially, GPS, GNSS gives you the physical location on Earth, and then the altimeter gives you a really high resolution elevation. So when you have to go to AFC for 6 gigahertz, not only do you have location, but you have very accurate elevation, which is kind of cool. In the past, there was no reason for a access point to have a altimeter inside of it. I talked a little bit about M12. One of the things we see for our industrial customers is the need to have, something more than RJ45 for high vibration environments. So think of things like on trains or on mine trucks. They have to drive over rocks a lot. If you're thinking about an RJ45, that basically is just held in with a little piece of plastic. That can come loose, that can get kind of pulled out, that can vibrate loose, even if you have a gland. So we have these adapters. I'll show you what the adapter looks like in a second. This is sort of the end result on, you take these ports, and I can unscrew one of these maybe real quick. Should have done this when I passed it around so you can see it. But essentially what you have inside that access point is just an RJ45 port, right? So without the M12, you just take a cable, plug it in there. You'd use a gland to keep it IP66, IP67 rated. But there's still concerns there that you have a gland, right? You're still sort of relying on that plastic clip to keep that connected to the access point. Adapter like this, you screw in, and then you have this connector. It's called an M12. Still has all 8 pins of the Ethernet cable, so you still get full PoE. These can support up to 2.5 gigabits per second throughput, but this actually screws into the access point. That way you have a very tight connection that is still waterproof. You don't have to worry about vibration. You don't have to worry about anything coming loose in some of those environments.
How does then the cable, you taking the pins, the individual cables out and getting them into those for copper?
How that plugs into the AP, or what the cable looks like?
Into that.
So the cable that you plug into the AP is pre-made with that M12 connector on it. You buy them that way. There are field termination ones, but usually it's pretty common that you just buy the pre-terminated M12 cable and plug that into the AP.
So then those are tested, so you're not worried about.
Yep.
Those are
Crimped
Yeah.
soldered.
Yeah, but yeah, usually they're all like plastic injected, molded together once they're made, so you don't have to worry about vibration in them. The biggest thing is getting rid of that little tiny plastic clip on the RJ45, right? Because RJ45, I mean, these have RJ45 in the back, but everything is captive, right? You're not relying on a piece of plastic. So this is what those ports looked like before. We actually do the same thing on the SFP port. You can use a GLC-TE, plug that in, and we have a little adapter bracket to make the spacing right, so you can use the adapter on it. This is didn't mention that, but this access points also can be powered via DC power. So this is a little microfit DC plug that you can supply DC power. We also have an adapter, M12 adapter that you plug in there, and then a different format of M12 allows you to plug in a power cable with the same thing. It's still M12, still IP66, IP67. That's actually quite common. It was in our previous access points, but it's also very common in industry to use kind of that M12 connector for power, because it's not something that can come loose very easily.
Is there a rubber seal on the cap then that you're putting in there?
I'll show you in a second. So, good question, right? It's what the next slide is. So this is what that adapter looks like from the back. So this is the RJ45 one. So, this is from the inside, what you plug into the AP. You have that RJ45 part that actually sticks inside, right? So again, it's still RJ45 internally, but it's actually, you screw that in with these screws, and then you have that seal there that that seals it to the AP. Very similar to the inside of this, you have something that looks like this, right? But there's the Ethernet. So this is sealed. There's a gasket on the inside of this on the outside, but that all comes from the factory pre-built. And then that seal is what seals against the AP.
And the 2 screws are what keeps it in place then.
Yep.
And the RJ45 one seems almost modular, so you don't have to replace the whole cap. Can you just replace the connector or the O-ring, and or do you have to replace the whole thing if you're just doing some maintenance on these?
You buy, like, we sell it all together. I mean, if the customer wanted to later, they could of course do whatever they want to here, but
But
you know,
that's the part.
that's the part. That's how it comes, right? So you basically buy this part, you stick it in the AP. This is all field replaceable, right? So it's really easy for them to do that on. Same thing with the power. Power is a little different though, because you have this little pigtail that you plug in the AP. In this case, you do have this little plastic clip, but that plastic clip on that connector is much stronger than the Ethernet one, right? I would have no problem taking that and like wheeling the access point around with it before it fails. More than likely, something else is going to pull out first, but.
That would have been a good demo.
So internally, right, I probably can't do this externally, but on the M12 side, I took an access point and started dangling it around by the M12 cable, and it took it just fine. With that, that kind of just adds into our final lineup of our Cisco Industrial Wireless portfolio. So this was the I version I talked about, but we also have an E version. We have a number of different other products that kind of come together. I'm not going to talk too much about this, but of course you have the slides and you can kind of look at what they look like afterwards. But yeah, so if you're interested, last year I talked about the E version, very similar, but now we're bringing that out in the I version as well, which makes a lot of people's lives a little easier when they're thinking about industrial wireless.